Right now, as you watch this, governments are spending billions on a tech most people have never heard of. Not AI, not rockets, something stranger. Something potentially far more powerful. A technology that could rewrite the rules of computing itself. It's called quantum computing. Welcome back. Today we're diving into the quantum computing race, the most important tech competition happening right now. We're going to explain what quantum computing actually is, who the main players are, and how AI is secretly powering this race.
Most importantly, why this matters to you, even if you've never written a single line of code in your life.
I promise to keep this simple. No jargon, no equations, just the story of the race to control the future. Because whoever wins this race won't just build a faster computer. They'll unlock new medicines, new materials, new power. This is the space race of our generation. But instead of the moon, the finish line is a computer that breaks reality. So let's start at the beginning. To understand quantum computers, you first need to understand regular ones. Let's go.
Your phone, your laptop, every computer today runs on bits. Think of a bit like a light switch. It's either off, 0, or on, 1. Everything digital, photos, emails, TikToks, is just billions of these switches flipping on and off incredibly fast. Quantum computers use qubits. And here's the weird part. A qubit doesn't have to be 0 or 1. It can be both at once.
We call this superposition, like a spinning coin. While it's spinning, it's both heads and tails. It only picks one when it lands. Imagine solving a maze. A normal computer tries each path one by one. A quantum computer explores all paths simultaneously. For the right kind of problem, it finds the exit almost instantly. That's the promise of quantum speed. There's a second trick called entanglement. Link two qubits, and what happens to one instantly affects the other. Doesn't matter if they're in the same room or light years apart. Einstein called this spooky action at a distance. So for problems like drug discovery, breaking codes, financial modeling, or simulating molecules, quantum could win. A task that takes a classical supercomputer millions of years could take a quantum computer just minutes. That's why this isn't just a tech upgrade. It's a whole new kind of machine, and everyone wants one. Which brings us to the big question. Who's ahead right now? Let's meet the main players in the quantum race. First up, the United States, the tech giant. IBM's been building quantum computers since 2016. You can even use one online. In 2019, Google claimed quantum supremacy. Their chip solved a problem in 200 seconds that'd take a supercomputer 10,000 years. Microsoft's betting on topological qubits, ultra-stable, and IonQ uses trapped ions, literal atoms, as their qubits.
China, the state-powered challenger. They're spending over 15 billion yuan annually. And they launched a quantum satellite. Baidu, Alibaba, and Origin Quantum are racing hard. In quantum communication, China might actually be ahead. Europe, the coordinated contender. The EU launched a €1 billion quantum flagship program across the whole continent.
Companies like IQM in Finland and Pascal in France are building hardware. Europe's strategy is teamwork, not one winner.
Japan's Fujitsu and Riken are world-class. And Canada punches above its weight. D-Wave built early commercial systems. Xanadu in Toronto uses photonic quantum computing. They use particles of light as qubits. Pretty wild. So who's winning? Honest answer, nobody yet. We're in the 1950s of quantum. Lots of rockets, no moon landing.
There are tons of failures, tons of breakthroughs. The finish line is close, but the race is still wide open. Now here's what most people miss. AI isn't quantum's rival. It's the engine driving the race. Here's how. Problem 1. Qubits are fragile. Heat, vibration, interference causes decoherence. The qubit forgets its quantum.
Google and IBM now use AI to predict qubit errors and fix them in real time, like an AI co-pilot fixing the engine mid-flight. Problem 2. Chip design. Quantum processors are insanely complex. AI tests millions of layouts before we build anything. Google used AI to help design their latest chips. Humans alone couldn't find these optimizations. AI can. For decades, human geniuses wrote quantum algorithms. Now, AI discovers new ones automatically. AI explores mathematical spaces no human would think to search, finding faster ways to use quantum computers. Problem 4. Access. Real quantum computers are limited, so we use AI to simulate quantum behavior on normal computers. It's like a flight simulator for quantum. We test ideas and train people before the real hardware is ready. So AI and quantum are in a feedback loop. Better AI builds better quantum computers. Better quantum builds better AI. Whoever masters both technologies first doesn't just win the race. They change the game entirely.
Which raises the question, if they win, what changes for you and me? Let's make this real. Because this isn't just about computers. It's about medicine, security, energy, and power. Let's break it down.
First, medicine. New drugs take a decade and billions. Quantum could simulate molecules perfectly, finding cures faster. Diseases like Alzheimer's or cancer could see new treatments discovered in years, not decades. That's the hope. Second, your security. All online encryption relies on math problems too hard for normal computers. Quantum breaks them. That means today's passwords could become useless, so everyone's scrambling to build quantum-proof encryption now. Quantum could design better solar cells. Third, climate and energy. Quantum could design better solar cells, room temp superconductors, and perfect climate models. Fourth, geopolitics. This is power. The first nation with large-scale quantum gets an edge in military, finance, science. Governments treat this like nuclear tech in the 1940s, with secret programs, export bans, and massive funding. We're living in Chapter 1 of the quantum era.
Most people don't know this race is happening.
But it's shaping our future. The tech is hard. Timelines are uncertain. But the destination is a computer that does the impossible. Who gets there first and what they do with it might be the biggest question of this century. Hit subscribe for more. See you next week.
Hey everyone, thanks so much for tuning in today. If you enjoyed this video and got some value from it, do me a huge favor and hit that subscribe button. It's totally free and it tells YouTube that you like what you see, which helps my channel grow and reach more amazing people just like you. I'm building a community here and I'd love for you to be a part of it. Also, your feedback is everything to me. Drop a comment down below and let me know what you thought. What was your favorite part? What would you like to see me cover next? I read every single comment, and your ideas really help shape the future of this channel. Seriously, your voice matters here. Thank you again for all your support. Don't forget to subscribe and comment. I can't wait to see you in the next video.